All right, guys, here we are with section 1.1, day 2. We are evaluating piecewise functions. So if you look at guided practice number 6 here, we've got the speed v of a vehicle in miles per hour can be represented by the following piecewise function, where t is the time in seconds. Find the speed of the vehicle at each indicated time. So if you look at this function here, you'll notice that this function is defined in what we call 3 pieces. So that's why it's called a piecewise function, is there's 3 pieces to my function. So between 0 and 15 seconds, it's going at a rate of 4t. Between 15 and 240 seconds, it's kind of coasting just here at 60 miles an hour. And between 240 and 250, it's got this function that applies. So when we're trying to evaluate v of 5, normally we would just plug 5 in for t, but now we've got 3 different cases. So our first step is to figure, where does 5 fit in our domains over here? So is 5 between 0 and 15, between 15 and 240, or between 240 and 250? So 5 is a number that's between 0 and 15, so that tells me I need to use that function. So for v of 5, I'm going to use 4 times t, which would be 4 times 5, which would be 20. And we're talking about miles per hour. All right, looking at b, for b, we're trying to find v of 15. So again, my first step, which part of this domain does it reside in? 15 could either be over here or here. So we're looking for where is it equal to? It's equal to on this domain here. So again, 4t is going to be the rule that I use. So this is going to be 4 times not t, but 4 times 15, which would be 60 miles per hour. And then last we got v of 245. 245 lies between 240 and 250. So I'm going to evaluate this function on this rule here. So instead of using the top 2, I'm using this rule down here. So negative 6 times not t, but 245 plus 1500. So negative 6 times 245 would be negative 1470 plus 1500. The difference between 1470 and 1500 would be 30 miles an hour. All right, just for grid's sake, let's choose something like v of, say, 200. Just because they didn't give this example, I still want to talk about it. 200 would lie between 15 and 240, so we're going to use this rule, which means I'm plugging in 200 everywhere I see t in this rule. But what's true about this rule? There is no t's, so I have nothing to plug in. My answer is just going to be 60 miles an hour. All right, that's evaluating. Got one more example here. We're talking about the average maximum height of children in inches. And it's defined in this piecewise function. It's a function of their parents' maximum heights in inches and can be modeled by the following piecewise function. Find the average maximum heights of children whose parents have the given maximum heights. Use h of x, where x is the independent variable representing the parent's height, and h of x is the dependent variable representing the child's height. And so here is my piecewise defined function. Again, I have 3 pieces to this graph. So for h of 67, my first job is to figure out where does 67 lie in these domains. Which one of these rules am I going to use? So 67 is not in this first one. 67 is between 66 and 68. So we're going to use this rule here. So this means we've got 3 times 67 minus 132. If you plug that into your calculator, it should spit out 69 inches. All right, for our second example, now we've got h of 72. 72 is bigger than 68, so it's going to be this last rule. So I've got 2 times 72 minus 66, which is 144 minus 66, which would give me 78 inches. So that's evaluating piecewise functions. We're going to do an example tomorrow where we're going to graph it since we struggled with it a little bit today. So look for that video tomorrow.